Hello and welcome back. We just took a look at finding some values for some trig functions. Let's do another example, and we'll see that something a little bit interesting happens with certain angles. So let's find the values for the 6 trig functions for the angle theta in standard position. So we'll draw a picture here in a second, whose terminal side ends at -1, 0. So -1, 0 is not very straight line. -1, 0 will be right along the x-axis. It's -1, so 1 to the left, but 0 up or down. So here we have the point -1, 0. And the angle that we're looking at, again, starts along the x-axis, which is the initial side, and goes to the terminal side, which is right here. So this angle happens to be 180 degrees. So it's exactly a straight line here. Again, we have x is going to be -1, y is going to be 0, and r is going to be fairly easy to figure out. So we take -1 squared plus 0 squared. And this is going to be the square root of, well, -1 squared is 1, plus 0 is still 1. So r is also going to be 1. Nice. So now when we look at our sine, cosine, and tangent, what we'll see is that sine, which is going to be y over r, so that's 0 divided by 1. This just happens to be 0. The cosine is x divided by r, so -1 divided by 1. Anything divided by 1 is just itself. And then the tangent, which is going to be y divided by x, which is also 0. Okay, so far so good. And if we start taking some reciprocals, we'll notice something a bit strange. The cosecant of theta is going to be 1 divided by 0, but we can't divide by 0. So what happens? Well, what we do is we say that this is undefined. So this function, if we think about this function, if we think about this as a function, if we plug 180 degrees into the cosecant, we would be supposed to divide by 0, so we can't. It's the same as if we had a function like 1 over x. We can plug 2 into that, we can plug -13 into that, but we can't plug 0 into this function. It's the same way. We can't plug 180 into the cosecant function because it's the same as dividing by 0. The secant, again, if we flip this over and we take 1 divided by -1, we still get -1. The cotangent, again, this is going to be -1 divided by 0, and we can't divide by 0. So in this case, this is undefined. And the abbreviation I'll use is UND, so undefined. So there are some angles that we can't plug into these values. In particular, the cosecant, secant, cotangent, and tangent are all functions that there are some restricted values. We can plug anything into sine and cosine. These 4 we'll have to be careful of. And it turns out that a lot of the angles that we need to be careful of are angles like this, which fall right along one of these axes, either a 0-degree angle, where the terminal side is exactly the same as the initial side, a 90-degree angle, 180. If it's pointing straight down, that's a 270-degree angle, or even a 360-degree angle, one full rotation. So I filled in this little table here. It's pretty easy to go through and actually verify some of these. So for instance, if we look at the 90-degree angle really quickly, we can have the point 0, 1, and so you can see that x will be 0, y will be 1, and r, the length of here, is just going to be 1. So x is 0, y is 1, and r is 1. So this is for a 90-degree angle. And then we can go through and the sine of this angle well, sorry, right here, the sine of this angle is going to be y divided by r. 1 divided by 1 is 1. X is 0, so 0 divided by 1 is 0. The tangent will be undefined because the tangent is always going to be y divided by x, which in this case is y divided by 0. Well, we can't divide by 0. So each one of these is fairly straightforward to go through. Just pick the point, say like 1 along each axis. So this is just a quick table showing you that sometimes these are undefined, sometimes they're 1, sometimes they're 0, or even -1. So these are just some angles to be aware of. One thing that I want to point out is the fact that the terminal side of an angle isn't always just defined by a single point. So we could imagine that we have, say, a line that comes up. And the angle here, we'll say that these both have the same angle. But maybe I pick this point here, and this is going to be my xy. Or maybe I pick this point up here, and this will be the xy in this question. So the r, for instance, is going to be a lot longer there. The r over here is going to be shorter. But I still get the same angle. So the question is, which is the right r, x, and y to use? The small ones, the small r, x, and y, or the big r, x, and y? And it turns out it doesn't matter what point we use, as long as they're along the same line to give the same angle. And this gives us a little bit of flexibility. So let's find the value of all 6 trig functions for the angle theta in standard position, whose terminal side is given by y is equal to 2x, and x is greater than 0. So let's break this down. We have our xy plane here. We also have the line y is equal to 2x. So for instance, we could go, so y is equal to 2x. If we think about y is equal to mx plus b, the intercept b is going to be 0, and the slope is 2. So we go 1 over and 2 up. 1 over and 2 up. So this line here is the line y is equal to 2x. So if I wanted to define an angle, there's a couple of angles that I could define. So if I do one in red, I could have the angle here and have this be theta. Or I could have the angle, again, starting from the x-axis, going all the way around and hitting down here. So the question is, which one do we want? Well, the original question gives us a little bit more information. We want x to be greater than 0. So where is x positive? It's to the right. So when we draw this line here, I don't want the entire line. I only want the line that extends to the right-hand side. So I'm not worried about the things down here. So this angle is going to come right there. This is the angle that we're worried about. Now, again, just like we mentioned before, it doesn't matter what point you choose along this line. You should always get the same values. So let's do this 2 ways. I'm going to use 2 different points here, and we'll see that we get the same values. I won't do it for all of them. But first, let's choose this point here. We went over 1 and up 2. So that point, x is going to be 1, since we went over 1, and y is going to be 2. R here, the length from there is going to be the square root of 1 squared plus 2 squared. 1 squared is 1, 2 squared is 4, so this is going to be the square root of 5. Sadly, we can't simplify this anymore. This isn't a nice Pythagorean triple, so we'll end up with a square root, which is fine. So let's really quickly calculate the sine of this angle. Sine is going to be y over r, so 2 divided by the square root of 5. Okay, so that's as simple as we can make it. I'm not going to rationalize the denominator. I'm just going to leave it as 2 divided by the square root of Let's choose a different point to see if we come up with the same value. So our slope was 2, so we went over 1 up 2. Let's go over 1 up 2 again. So now let's try this. So x is going to be 2. Y, we've gone up 4 now. Let's find r. Again, r will be 2 squared plus 4 squared, and we'll take the square root of everything. 2 squared is 4. 4 squared is 16, so it's going to be the square root of 20. We'll notice that 20 is actually going to be 2 root 5. I can pull a 4 out of here. So 20 is 4 times 5. So by taking the square root, it'll be 2 root 5. And if I write the sine of theta, y divided by r, this is going to be 4 divided by 2 root 5. And when I cancel, I'm going to get 2 root 5. Again, I can cancel 2 off the top of the bottom. So I get the same value for sine. And it doesn't matter which point I choose. So if it doesn't matter, we might as well choose the one that requires less reducing. These numbers are just slightly bigger. So we'll use these guys, just 1, 2, and square root of 5. So if I try to find the sine, which we already have, we've got the cosine of theta, which is going to be x divided by r, so it's going to be 1 over root 5, and the tangent, which is going to be y divided by x, so 2 divided by 1 happens to be 2. So this is the exact angle where the tangent's equal to 2. We also have the cosecant, which is going to be the reciprocal of this, so this is going to be the square root of 5 over 2. We've got the secant, which is going to be the square root of 5 divided by 1, which is in fact just the square root of 5. Nice. And the cotangent, which would be 1 divided by 2. So again, each of these values is fairly straightforward if we know x, y, and r. And I think I will stop here and do a little bit more in one more video.